if 2 cos squared phi is equal to tan squared phi, where phi is between 0 and pi over 2, find phi. So now the question is 2 cos squared phi is equal to tan squared phi. So we can express tan squared phi in terms of sine and cos, because we know that tan phi is equal to sine phi over cos phi. So 2 cos squared phi is equal to sine squared phi over cos squared phi. So if we multiply through by cos squared phi, we are going to get 2 cos squared phi times cos squared phi is equal to cos squared phi times sine squared phi over cos squared phi. So at the end of the day, this cos squared phi and cos squared phi can cancel. So we are going to get 2 cos phi exponent 4 equals sine squared phi. But we know that from trig identities, cos squared phi plus sine squared phi is equal to 1. So this implies that if we make sine squared phi the subject, then sine squared phi is equal to 1 minus cos squared phi. So we can then replace this sine squared phi with cos 1 minus cos squared phi. So it becomes 2 cos phi exponent 4 equals 1 minus cos squared phi. So continuing from here, let's take everything to the right hand side of the equation. So it becomes 2 cos phi exponent 4, then plus cos squared phi, then minus 1 is equal to 0. So let me write this well. So here's exponent 4. So now, how do we solve this equation? What we can do is to say, let cos squared phi to be equal to capital A. So that now we can then say, let's rewrite this equation. We can write this as 2 cos squared phi, then I want to put this into bracket, squared, then plus cos squared phi minus 1 equals 0. So that at the end of the day, this becomes 2a squared, because cos squared phi is a, then plus a minus 1 is equal to 0. So we see that we then get a quadratic equation in the form of ax squared plus bx plus c is equal to 0. So we can use the quadratic formula. Now, remember that the quadratic formula, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So in this case, then a is equal to minus b, the coefficient of a is minus 1, plus or minus square root of b squared, which is 1 squared, minus 4 times a is 2 times c is minus 1, all divided by 2 times a, which is 2 times 2. So a is equal to minus 1 plus or minus, now here becomes square root of 1 squared is 1, then minus 4 times 2 is minus 8 times minus 1, it becomes plus 8. So plus 8 divided by 2 times 2 is 4. So a is equal to, now 1 plus 8 is 9, root 9 is 3, so it becomes minus 1 plus or minus 3 divided by 4. But remember that phi is between 0 and then pi over 2. So it means that now let's write the possible values of a. So the possible values of a is equal to minus 1 minus 3 divided by 4, or a is equal to 3 minus 1 divided by 4. So in this case, a for this one is equal to minus 1 minus 3 is minus 4 divided by 4, which becomes minus 1, or 3 minus 1 is 2, and 2 divided by 4 is 1 over 2. So the values of a are a equals minus 1 or 1 over 2. So now, considering these values of a, remember that we said we should let cos squared phi to be a. Now a cannot be minus 1, because if we put minus 1 here, we are going to run into imaginary numbers, and we don't want to use imaginary numbers here, because phi is bounded by 0 and pi over 2, and therefore the value of a can only be one value, which is a equals 1 over 2. Now remember that we already said that cos squared phi is equal to a, so that it implies that cos squared phi is equal to the value of a, which is 1 over 2, and therefore cos phi is equal to 1 over root 2, and therefore phi is equal to cos inverse of 1 over root 2 is the same as root 2 over 2, and therefore phi is equal to 45 degrees. But this same 45 degrees is the same as pi over 4 radians. So therefore phi is equal to pi over 4.